start. The title in the freedom to think about what to talk about, and then it gave me the opportunity to tell you about some very new results, if I had some at this. And everyone a winner, then the title continues or something, and so a little bit about what this will be about then. Now, or on Kirkman triple systems of order 21. And last winter at some point I had a grand plan that this would be the perfect place to you know, if I could classify these together with my former student Janne Kokkala, then we could present those results here. Now unfortunately hard work didn't yet lead to that classification, but still I have partial classification results to talk about and various other issues related to Kirkman triple systems. So let's start with the definitions. Very well known to most of you, maybe not all of you. So standard triple system of order B, collection of 3 subset blocks of VZ points, so that each 2 subset occurs in exactly 1 block, and these are abbreviated as ESB. Now, if we can partition the V points into blocks, standard triple system, and this is called a parallel class, and if we can partition all blocks into parallel classes, then we have a resolution, and then a standard triple system, and corresponding resolution is then a Kirkman triple system of order B, and this is abbreviated KTSB. Now these are very old results from the 19th century and 20th century. We have standard triple systems if and only if is congruent to 1 or 3 modulo 6. Now to be able to partition points into blocks, see that this 1 is not possible, but for V congruent to 3 modulo 6 this is always possible. So now about resolutions, you can continue here now this sequence of definitions and think about standard triple systems that can be resolved in several ways, and if you have 2 resolutions, so that if you take 2 parallel classes, one from each of the resolutions, then they intersect in at most 1 block, then you have a doubly resolvable standard triple system, and you can even continue and think about sets of 3 standard triple systems and so on. But so for doubly resolvable ones, so this property that you can the intersection is at most 1 block. This means that you can draw a picture like this. This is a doubly resolvable standard triple system of order 27, copied from a paper of Charlie and co-authors. So the names of the points are a little bit strange, because this kind of comes from how this was constructed, but anyway you have triples here, and now rows are parallel classes of one resolution, and the columns are parallel classes of another, and really as the intersection is always at most 1, then you can always present a doubly resolvable standard triple system in this way. this example shows that the Steiner triple system of doubly resolvable Steiner triple system of order 27 exists. But what about the general case? Well, since these are Kirkman triple systems, then B has to be congruent to 3 modulo 6, and well, do these exist for all of these admissible parameters? Well, this is again where Charlie has been involved, and it turns out that with a few exceptions, this is indeed the case. So for 9 and for 9 and 15, there are no doubly resolvable Steiner triple systems, and then there are a few handful of other cases where we don't know what's going on, and this list is getting shorter. People are finding these structures, and now currently the list starts, the exception starts 21, 141, and so on. And so we have a quite small number here, and then some bigger ones. And I guess people working in this area conjecture that all these bigger ones, they really exist, and it's just a matter of constructing them. But then we have the annoying small 21 here, and you can see it's right between non-existence and existence, so could exist, maybe not. And in the literature, every time people have constructed Kirkman triple systems for the 21, or some Steiner triple systems for the 21, this is kind of the first thing you do is you check maybe you could have found some doubly resolvable ones, and this is really a problem that many people are interested in, and should be settled at some point. And the related problem is kind of the problem of classifying Kirkman triple systems of order 21 is related because if you are able to classify those, then it's rather easy to check whether they are doubly resolvable or not. And along the years, I know that Charlie worked, for example, with Patric, I think it was around 2006, when he made some serious attempts on both problems. I myself worked on it in 2010, and then Janne Kokkala, my students, 4 years later, and now again 4 years later this year we made further attempts. It's a hard problem. Okay, I'll continue now talking a little about how I prefer to think about these objects, and codes. Codes are the framework where I like to place these. So if you think about, start from Steiner triple systems, Steiner triple systems can be looked at as constant weight codes, and now you can do it looking at the columns as code words, but I'll not do that. I'll look at the rows at code words. So this is an incidence matrix of a Steiner triple system of order 9, small enough to fit on this page. So you can see the code words, they have length 12. The code has size 9. There are 9 code words, and there are 4 ones in each row, so you have constant weight 4, and then you have minimum distance 6. The having distance between 2 code words is is at least 6. It's actually exactly distance, exactly 6 between any pair, but when you look at these, actually you you might as well look for something with this, where the distances are at least 6, and you find 9 such code words. You don't even need to care about that. There should be three ones in each coordinate. This will automatically happen. And so in our case, STS-21, you have bigger parameters, but same situation. Okay, so what about Kirkman triple systems? The same thing. You can look at them as codes, different types of codes. Now I have here the parallel classes as columns of a KTS9. And now again the code words are the rows. KTS9, we have a ternary code, value 0, 1, 2, length 4, 9 code words, minimum distance 3, actually the Hamming code, and again, search for something like this. You don't need to care about how many zeros and ones there are in columns. Everything will come nicely, and for KTS-21, bigger parameters, alphabet size 7, length 10, size 21, minimum distance, instance 9. And kind of what I personally like myself about the framework like this is that now we are not looking for objects with some properties, but we are just looking at objects, kind of. What about doubly resolvable ones? Well, these are actually also codes. And now we don't have any small examples.